And we're back. Okay, so at this point, we can do sums and differences, e to the x, products, and quotients. 2 seconds in. I already have an interruption. Okay. We're going to take a pause in learning how to take derivatives of new types of functions to talk about what are called higher order derivatives. And then after we do higher order derivatives, we'll move on to things like trig functions and some even more exciting types of functions. So what I want to talk to you quickly today about is higher order derivatives. So when we take a derivative, so when I say to you, take the derivative of, or find f prime of, or find f prime, sorry, what I'm really saying is to take the first derivative, and no one says that, right? When we take a derivative, the assumption is that we want what's called the first derivative. Okay. But there are other derivatives that we can take that will become useful to us in calculus. They're going to give us a lot of information about the function, and we call those higher order derivatives. Basically, what a higher order derivative is that it's a derivative of a derivative. So I take my first derivative and then I take it again. And I note that I call it the second derivative, and notice instead of 1 tick mark, it has 2 tick marks. So if I want to find f double prime of x, or my second derivative, so I call this f double prime, that's literally read like that, or my second derivative, I'm going to take the derivative, and then I'm going to take the derivative of my derivative. You can probably guess what happens if I then take the derivative of that. If you take the derivative of your second derivative, it becomes your third derivative, or f triple prime of x. Okay? You can keep going forever if you'd like. Okay? When you take the derivative of the third derivative, you get the fourth derivative. And it's worth noting that at this point, this is where notation changes. So this is really important to note. We use tick marks for first derivative, second derivative, and third derivative. After that, we don't continue using, I don't know, like Roman numerals or something up here. So for the fourth derivative, what we do is we put the number of the derivative and we put it in parentheses. Put it in parentheses, but because we don't want to confuse it with raising the function to the fourth power. When you see that number in parentheses, it means the fourth derivative, and that's important notation to know. So you could see any number in here, any number at all. That might say 27 up there. That means you need to take the derivative 27 times. Now, interestingly, you would think they're not going to ask me to do that, but sometimes they ask you to take a really extraordinarily high order derivative not because they want you to actually do it, but because there's a theory behind it, and you should be able to know the answer without actually doing it. And we'll talk about that a little bit on the next couple slides. All right, so again, this is mostly notation. We're going to be using the same derivative rules. It's just that we're going to be using them repeatedly. So again, prime, double prime, triple prime, and then after that it's fourth derivative, fifth derivative, and we see the numbers in parentheses. So let's look at a couple examples. First example, if I have f of x equals 2x to the 7th, if I take the first derivative of that, f prime of x, I'm going to multiply the 7 down, I get 14x to the 6th. Okay. So if I want the second derivative, I'm literally just going to take the derivative of 14x to the 6th. So 14 times 6 is 84, so that becomes 84x to the 5th. I can take the third derivative. Let's see, 84 times 5 is 420. X to the 4th. Again, every time I take a derivative, it knocks down 1. So I want you to notice here that for this polynomial, eventually, times 4, my fourth derivative is 1680. Eventually, I'm going to run out of x's here. And so for polynomials, the derivatives eventually go away, if you will. In other words, by the time I get into my higher order derivatives, they're going to go constant. So this is x. My seventh derivative is going to be just the number, and then my eighth derivative is going to be 0. So I want you to notice something. I started out with seventh order, and look how many derivatives I got before it went to 0. If you have a seventh order equation, you can get up to the seventh derivative if it's a polynomial, because it knocks down one every time, right? So if you have it to the seventh, you can get all the way down to the seventh derivative. It'll be a constant. Anything after that, it's going to be 0. So I could give you this equation and say, find the 80th derivative. 0. Right? Anything after 7 is going to give me a 0 derivative for a polynomial, right? For the polynomials only, we know that when we take derivatives, it knocks it down. So every time I take a derivative, it knocks it down. So it's only ever going to go as far with higher order derivatives as its power. Okay, so something like this, if I wanted to take a couple derivatives, as you can see, my highest order here is 3. So I'm only going to get to the third derivative before I'm staring at a constant. So if we take our first derivative, we get 9x squared plus 2x. When we take our second derivative, I get 18x plus 2. I take my third derivative, I'm down to 18. Anything after my third derivative, fourth derivative and on, is going to be 0. And so we're just taking derivatives of derivatives here. Then you get to something like, I hope you can see this, it says f of x equals e to the x. Now think about this. F prime of x, the derivative of e to the x is e to the x. F double prime of x, it's still e to the x. It doesn't matter how far down you go. Every derivative of e to the x is going to be e to the x. Okay? So they could say to you, f of x is e to the x. What's the 127th derivative? E to the x. Okay? So it's little kind of theoretical questions like that where they're wanting to know if you know the notation, and also wanting to know if you know kind of these basic things about derivatives, that polynomials will eventually go away under higher order derivatives, e to the x is always going to stay the same, and then we see some other patterns with different types of functions as well. Okay, so these ones are pretty basic higher order derivatives, but I do want to show you that sometimes they can be a little bit of a pain in the butt. So notice here, I have f of x is x to the 5th times e to the x. This is a product, right? So it wants me to find the second derivative here. Well, the first thing I have to do is find my first derivative. So I have a product here. I have an x to the 5th and an e to the x. So when I take my derivative, x to the 5th times the derivative of e to the x plus e to the x times the derivative of x to the 5th, which is 5x to the 4th. So fine, I'm going to write, I don't know why I do this, but I have to put that 5 out front. I have to. Okay, this is my first derivative. And so notice when I go to take my second derivative, what I have here, I have a product plus another product. So if you take the second derivative of this, you're going to have to do a product rule and another product rule. So it's the sum of two products. So now I'm going to have two product rules. Okay. You do have another option. In this particular case, you could factor this e to the x out. Maybe save yourself a little bit of calculus work with a little bit of algebra. If you factor the e to the x out, you get x to the 5th plus 5x to the 4th. So with one little step of algebra, now what I've done is I've rewritten my equation so that I no longer have two product rules, now I just have one. So instead of the sum of two products, I have a product that involves a sum, but taking the derivative of a sum is no big deal at all. So if I want my second derivative now, oops, sorry. It's a little easier because I only have to do the product rule once. So it'll be e to the x times the derivative of this. So 5x to the 4th plus 20x cubed plus my second chunk, second derivative. Now, they ask you for the third derivative. Again, here we're lucky. We could take the e to the x out. But if we weren't lucky, we would have to do two products. So higher order derivatives with things like product rules can really explode, especially if you can't simplify, because every product, when you take its derivative, gets written into two. So if you take the second derivative, you end up having 4. And you take the third derivative, you end up having 8. They just grow. The number of products you have grows exponentially. Quotients, you can imagine, are super fun. You get when you take the derivative of a quotient, you get another quotient. So they can be kind of complicated depending on the function. But the key here is to know the notation and know what they're asking. For the most part, we use first, second, and third derivatives because those are the ones that give us valuable information about the function. After that, if they're asking us for higher than that, it's a kind of a theoretical question. Okay, so we will do some practice with that during class tomorrow, and just let me know if you have any questions, and I will see you soon.